Welcome back to a new lecture in the Prompt Engineering course. In this session, we will dive into different prompting techniques, such as zero-shot prompting and few-shot prompting. These methods can help tackle real-world problems effectively. So let's jump right in. The first one is zero-shot prompting. So what is zero-shot prompting? This is an instruction-based prompting technique. This is where you ask the AI a question without providing any examples. This prompting technique is beneficial in contexts where you need a quick, general response based on a model's pre-trained knowledge, such as answering simple factual questions, summarizing information, classifying content, performing basic translations, sentiment analysis, generating creative ideas, exploring new topics, and providing initial insights without requiring specific training data for each task. Now, let us see specific use cases of zero-shot prompting. Imagine you need to write a formal business email requesting a meeting with a potential client to discuss a new product line. Without providing any examples, you simply give prompt to an AI model, write a formal business email requesting a meeting with a potential client to discuss a new product line. The AI generates the following response. Subject, request for meeting to discuss our new product line. Dear client's name and so on as shown in the slide. But why does zero-shot prompting work? This method works well because large language models like ChatGPT are trained on vast amounts of data. They can recognize patterns, recall information, and generate responses based on the knowledge embedded during their training. In our example, the model has learned about professional email structures, business communication etiquette, and the key components of a meeting request. That's why it can generate a polished email, even without prior examples. Now let us move to another use case of zero-shot prompting, which is content categorization. Zero-shot prompting enables AI models to classify text into predefined categories without requiring prior training on labeled datasets. This is particularly useful for organizing large volumes of information efficiently, as the model relies on its pre-existing knowledge to determine appropriate classifications. News organizations, blogs, and content platforms can use zero-shot prompting to automatically categorize articles based on their topics. For example, if we give the following prompt to AI model, classify the following article into one of these categories: politics, technology, sports, or health. Model will give us output as category health. But why does it work? It works because the model identifies key terms, like medical diagnostics and doctors, to classify the article under the health category. And the best part? There is no prior training on a specific dataset is needed. Just clear instructions on category options is required. The same process occurs in the below example as shown in the slide, where we classify documents into the following categories: finance, HR, R&D, and marketing. The output is marketing because the model recognizes that terms like market trends, customer behavior, and advertising are related to marketing. Again, let us see another use case, which is language translation. Zero-shot prompting allows large language models to perform language translation without being explicitly trained on specific language pairs. Since LLMs are pre-trained on vast multilingual datasets, they can generalize their knowledge to translate between different languages. For example, translate the following English sentence into Spanish. The weather is beautiful today, and I plan to go for a walk in the park. And AI model translate it into Spanish as shown in the slide. Why it works. The model has seen both English and Spanish texts during pre-training and understands their grammar and vocabulary. It does not need explicit training on English-Spanish translation pairs. It can infer the correct translation from its linguistic knowledge. Same thing happened in below example, where businesses operating globally can use zero-shot prompting to communicate with customers in different languages without needing separate translation models for each language pair. Now that we have covered zero-shot prompting, let us move on to few-shot prompting. So what is few-shot prompting? Few-shot prompting technique improves AI performance by including one or more examples in the input prompt. And this helped the model to understand the task better and generate more accurate responses. A variation of this is n-shot prompting, where n represents the number of examples provided. If we provide 0 example, then it is called zero-shot prompting. If we provide 1 example, then we called it as one-shot prompting, and so on. The more examples we provide, the better the model understands the context of the task. Now, why use few-shot prompting? It is particularly useful for handling complex tasks. Zero-shot approaches often struggle with tasks that require deeper context or reasoning. By providing examples, we guide the model to better comprehend and execute complex instructions. Reducing hallucinations. AI models sometimes generate incorrect or irrelevant responses. With few-shot prompting, the additional context helps the model stay aligned with the intended topic, reducing the risk of hallucinations. Personalization. AI can be tailored for specific use cases, such as customer support chatbots. By providing domain-specific examples, we improve response quality and relevance. Few-shot prompting is a simple yet powerful technique to enhance AI performance across various applications. Improving model adaptation to new data. When working with specialized domains like legal, finance, or medical data, the model might not always generalize well. Adding domain-specific examples helps the AI adapt to the terminology and structure of new datasets without requiring fine-tuning. Debugging AI outputs by adding targeted examples. One of the most practical uses of few-shot prompting is debugging. If we notice that the model is consistently making errors on certain types of inputs, we can introduce examples that clarify the expected response. This iterative approach helps refine AI performance over time. So as we can see, few-shot prompting is a powerful tool that enhances accuracy, reliability, and adaptability in AI models. Next, let us explore where it can be applied in real-world scenarios. Few-shot prompting is a versatile technique that enhances AI performance across various applications. Let us look at some key areas where it proves to be useful. Content generation with style control. By providing a few examples of the desired writing style, whether formal, informal, or humorous, we can influence the tone and voice of AI-generated content. This is particularly useful for marketing copy, blog writing, or personalized communication. Information extraction from OCR data. We can use few-shot prompting to extract structured information from OCR-processed text. Since OCR often distorts text formatting, we included examples of broken text and their intended structure. This significantly improved the model's ability to recognize and organize the extracted information. Domain-specific tasks. Few-shot prompting helps adapt AI models to specialized fields. For instance, in medical diagnosis, providing a few examples of patient symptoms with corresponding diagnoses helps classify new cases. In legal document analysis, showing labeled examples allows AI to extract relevant information more accurately. Similarly, in financial analysis, a handful of labeled news articles can guide the model in classifying market sentiment. Customer service chatbots. Chatbots can be personalized to match specific business needs. By including a few sample conversations, we can train AI to respond in a way that aligns with company guidelines, user preferences, or even regional language nuances. Code generation with example snippets. When developing software, we can use few-shot prompting to guide AI in generating relevant code. By providing a few example snippets, the model learns the required syntax, logic, and formatting. This makes it more efficient for coding tasks like automation scripts, data processing, or API integrations. Fine-tuning output formatting or structure. Few-shot prompting is particularly useful when we need to enforce a specific format in AI-generated outputs, whether it is structuring a report, summarizing data in a predefined way, or aligning with company-specific document templates. A small set of examples can help the model follow the required structure consistently. These are few real-world scenarios where few-shot prompting can enhance AI capabilities. So let us understand few-shot prompting with an example. Imagine you want an AI model to generate compelling product descriptions for an online electronics store. For that, consider the following zero-shot prompt, where no example is given. You are a product description writer for an online electronics store. Your task is to generate a compelling product description for a Bluetooth speaker. Here, ChatGPT output is very general. The model understands the request and generates a general product description. The response is correct, but lacks structured alignment with any specific writing style. Now, instead of giving it just a single instruction, we provide a few examples of well-written product descriptions to guide its response. This approach is known as few-shot prompting, And here, if you provide one example, then this is called one-shot prompting. If you provide two examples, then this is called two-shot prompting. Now, consider the following example, which is presented in the slide. The prompt is illustrated along with an example for better understanding to AI model. You can see the output of AI model in the slide. The response is now more aligned with the format of the example. The structure of the output closely matches the wireless earbuds description, for example, sentence length and wording style. The example provides a clear reference, helping the model understand the expected tone and style. Now let's increase the number of examples to 2, and for that, the prompt is shown in the slide. Here we use 2 examples, so we called it as two-shot prompting. Here, the AI output is product, Bluetooth speaker. Description: this Bluetooth speaker delivers powerful, crystal-clear sound with deep bass, and so on, as shown in the slide. Now, how did the AI generate such a well-structured response? What is the effect of more examples? When we provide more examples, the model becomes more consistent with the established style. It follows the same structure, starting with the product type, describing key features, and ending with an ideal use case. The language is refined and aligns with the given examples, ensuring uniformity across different product descriptions. The more examples we provide, the better the model understands the expected output pattern. However, it is important to maintain a balance. Examples should be diverse enough to cover edge cases. This ensures the model can handle variations in input effectively. At the same time, providing too many examples can reduce the model's ability to generalize, making it overly dependent on specific patterns. Striking the right balance between quantity and diversity is key to optimizing few-shot prompting. Now let us explore another use case of few-shot prompting, extracting structured information from OCR data. When dealing with OCR-generated text, providing a well-designed prompt is crucial for achieving accurate results. Here, we have an original document that needs to be extracted using OCR, as demonstrated in the slide. Let us first evaluate how zero-shot prompting performs in extracting information from the OCR extracted data. In this attempt, we instruct the model, "You are a medical expert specialized in cancer radiation therapy." We also provide the OCR extracted document as input and specify the desired output format, as shown in the slide. Now let us analyze the output. Here, we observe several mistakes, such as date formatting errors, where the model fails to standardize dates correctly, misinterpretation of data, leading to inaccuracies in extracted values, ambiguity in extraction, where critical variables are not recognized consistently. These errors occur because the model relies only on its general knowledge and pattern recognition without specific guidance. This highlights the limitations of zero-shot prompting when dealing with structured data extraction. Now that we have seen the limitations of zero-shot prompting, let us explore how few-shot prompting can significantly improve accuracy. In this case, we use the same instruction. "As you are a medical expert specialized in cancer radiation therapy." We also provide the same input document and specify the same output format. However, this time we include structured examples in the prompt, as shown in the slide. By including structured examples in the prompt, we guide the model to correctly extract dates in a standardized format, properly recognize fractions rather than misinterpreting values, avoid typos and inconsistencies in numerical values, apply consistent formatting to ensure JSON compatibility. Now we can see that the output is accurate and well-structured. This technique is especially valuable in real-world applications, where structured data extraction from unstructured text, such as OCR outputs, is critical for automation and decision-making. Now, let us break down how few-shot prompting actually works and why it improves AI model performance. Iterative example addition. The process of few-shot prompting does not start with a fixed number of examples. Instead, we begin with zero-shot prompting, meaning we give the AI a task without any example and observe its output. If the model makes errors or struggles with certain inputs, we analyze the mistakes and introduce specific examples to address them. This iterative approach helps refine the model's understanding. For example, imagine we are building an AI to classify customer complaints into categories like billing issue, service disruption, and technical support. If the AI misclassified certain complaints, we identify the problematic cases and include a few labeled examples to guide the model. For instance, if my internet speed is too slow, is mistakenly categorized under billing issue, we add an example. My internet stopped working for an hour. Category service disruption. Over time, the model improves its classification accuracy. Contextual learning. Few-shot prompting helps AI models learn contextually by recognizing patterns in structured and unstructured data. When we provide well-chosen examples, the AI picks up on formatting, tone, structure, and relevant patterns to generate more accurate responses. For example, consider a chatbot that summarizes emails. If we provide an example like input, "Hi John, just following up on the project status. Let me know if you need any details." Expected summary, follow up on project status. The AI learns how to extract key information. If it initially produces overly detailed or irrelevant summaries, we refine its output by adding more examples demonstrating the desired brevity and structure. Adaptation to real-world inputs. AI models often struggle with messy, real-world data like incomplete sentences, typos, or inconsistent formatting. Few-shot prompting helps the model adapt to these challenges by exposing it to real-world variations through examples. For example, in any OCR-based document extraction project, when PDFs were converted to text, the structure was lost, making it hard for the AI to extract relevant details. We solved this by providing before and after examples, showing how broken text corresponds to structured data. This helped the model understand and reconstruct meaningful information from unstructured inputs. We have seen how few-shot prompting improves accuracy. Now let us discuss how to use it effectively. Here are some key tips. The first one is, use relevant examples. The examples you provide should closely match the actual task you want the model to perform. If the examples are not relevant, the model may generate inaccurate or misleading outputs. Start with zero-shot and adjust. Instead of adding multiple examples right away, it's a good practice to begin with a zero-shot prompt, where no examples are given. Then analyze the output and add examples step by step, refining based on errors and improvements you observe. Maintain a clear format. Consistency is key. If all examples follow the same structure, the model can better understand the pattern and generalize more effectively. This reduces ambiguity and improves the accuracy of responses. Diversify input types. Do not just use similar examples. Try including different variations, especially edge cases, like unusual or complex inputs. This makes the model more robust and capable of handling diverse scenarios. Monitor and iterate. Few-shot prompting is not a one-time setup. Continuously analyze the model's outputs, identify areas for improvement, and refine the prompt as needed. Iteration is essential to achieve the best possible performance. By following these tips, you can optimize few-shot prompting and get better results from AI models. While few-shot prompting is a powerful technique, it comes with some limitations. Higher token usage and cost. Using multiple examples in a prompt increases the number of tokens used. This leads to higher processing costs, especially for large-scale applications. Reduced generalization. The AI may rely too much on the provided examples, limiting its ability to handle completely new or unseen situations. Instead of applying broad knowledge, it might mimic the patterns from the examples too rigidly. Missed edge cases. Since the AI learns from specific examples, it might struggle with rare or unexpected inputs that were not covered in the prompt. This can lead to inaccuracies or incomplete responses in unique scenarios. Understanding these limitations helps in designing better prompts that balance effectiveness with efficiency. To overcome the challenges of few-shot prompting, several strategies can be used. Optimize examples. Select concise, high-impact examples that effectively demonstrate the task while minimizing token usage. This helps maintain efficiency without sacrificing performance. Ensure that the examples are directly related to the task you want the model to perform. Irrelevant examples can confuse the model and lead to poor performance. Use a diverse set of examples that cover different aspects of the task. This helps the model generalize better to new inputs. Examples should be clear and unambiguous. Avoid complex or convoluted examples that might confuse the model. Diversify training. Regularly update examples with new data, including edge cases identified through user feedback. This broadens the model's generalization and improves accuracy across different scenarios. Avoiding overfitting. To optimize few-shot prompting, it is crucial to prevent overfitting. Overfitting occurs when a model memorizes examples instead of learning to generalize. Let us explore how to avoid this and ensure better adaptability. For that, use diverse examples. Providing a variety of examples helps the model understand different scenarios rather than just replicating patterns. Limit the number of examples. Using too many examples can lead to overfitting. A few well-chosen examples are often more effective than an excessive number of similar ones. Test and adjust for generalization. After designing the prompt, it is essential to test the model's performance on new inputs. This helps identify areas where it may struggle to generalize. Provide a structured response format. Beyond examples, defining a structured response format improves consistency. A well-organized response template ensures clarity and relevance. For instance, if a user reports, "My Jupyter notebook is not working," a structured response could be, "Hey name, we are very sorry to hear that. We have registered your query and our team is looking into it. As soon as we fix it, we will notify you. Thanks for reaching out. If you have any questions, feel free to ask." Here we can see this response follows a structured format: apology, acknowledgement of the issue's solution, future update, reassurance. By using this approach, responses remain relevant and adaptable across different situations. By applying these best practices, diverse examples, controlled example count, regular testing, and structured responses, we can optimize few-shot prompting for efficiency, accuracy, and adaptability while minimizing the risk of overfitting. And that brings us to the end of this session. In this lecture, we explored prompting techniques such as zero-shot and few-shot. Understanding these techniques helps in crafting better prompts, leading to more accurate and meaningful AI responses. Thank you for joining this session. Let us continue our journey into the world of prompt engineering in the next video. See you there.